This is a great little task that I use all the time in the classroom once pupils are familiar with zero pairs. And I really like it because it gives pupils a chance to behave mathematically. So the idea is quite simple. We start off with this growing pattern and we work out the value of the pattern at each term. So you can see here we've got this growing triangle here and alternate rows are positive, negative, and so on. So the prompts are quite simple. Work out the sum of the fourth pattern, then the sum of a pattern further down the line, and then finally can you generalise to the sum of the nth pattern? And if you can do that, can you then make some patterns of your own and can you generalise those patterns as well? So have a little think about the task and then I'll talk you through it in the next part. So the idea is you bring up this pattern here and you say, assuming that the yellow count is a positive 1 and the red count is a negative 1, what's the value of this whole triangle? So make up your zero pairs and what you're left with, that's the value of this triangle here. So they might say, okay, that's a zero pair here, all these three here, and there's another zero pair there. So you can see the value of this triangle would be negative 2. Now this triangle has 4 rows, if you like, 1, 2, 3, 4. But what if we added another row on the bottom, or another row, or 10 more rows? What would these values be as we do that? So here's an opportunity to work systematically, set it out in a nice neat table and behave a little bit mathematically. So what do we know so far? So let's set our table out. And we're considering basically how many rows this pattern has and what's the sum of all the counters. And we've worked out the first one. We know that when we've got 4 rows, you can see we've got this total sum of negative 2. Oh, that's one big zero pair. We've got a sum of negative 2. Now, we could work down here, 5 rows, 6 rows, 7 rows, but it makes sense to specialise towards simpler numbers to begin with. So what if we went to 3 rows to begin with? Can we start to spot any patterns? So let's remove this 4th row briefly. And what's the sum now? Now hopefully you can see we've got this zero pair here and we're left with an answer of positive 2 for our sum here. So we've gone from negative 2 to positive 2, which is something to notice, potentially interesting. Okay, let's specialise further and go to 2 rows now. What happens when I go to 2 rows? Well, now my answer swung round to negative 1. And then the very specialised case, when we've just got 1 row, obviously we're going to swing round to positive 1 as well. And by the time you get to this stage on the board, students should notice something and be in a position to maybe make a conjecture or what they think might happen next. Because we've got this pattern of positive 1, negative 1, positive 2, negative 2. What do we predict the 5th row would be? And hopefully they might say, oh, it's going to be positive 3 because that continues this pattern here. So let's just go back to 4th row, to the 4th rows here. So there was our negative 2, if you remember. And then get them to consider and get them to verbalise, okay, what's physically happening as I add another row onto this pattern? What counters am I adding? Are they positive? Are they negative? And how many of them? So we're adding 5 positive counters to this. So we're starting off at a point where we're at negative 2 for the whole expression. And if I add on 5 positive counters, it makes sense that I'm going to swing from negative 2 round to positive 3. And then again, the next one after that, if I go to the 6th row, what am I actually doing? I'm adding on 6 negative counters. So if this whole thing is worth positive 3 and I'm adding on negative 6, we're going to swing round to negative 3. And you can see if we're on an even number of rows, we'll be adding on negative counters, and if we're adding on a positive number of rows, we'll be adding on positive counters. And that can give us some insight into what the general rule would be and help us find what maybe 10 rows or 100 rows or 50 rows would be. So let's consider the 10th row. What do we think that would be? Well, if 5 and 6 give us positive 3 and negative 3, then 7 and 8 would give us positive 4 and negative 4. So 9 and 10 would give us positive 5 and negative 5 for the 5th row. And then get them to consider odd and even rows now. Whenever we hit an even row, so 10, 6, 4 and 2, our sum is always negative. And whenever we hit an odd row, so 1, 3, 5 and so on, we always get a positive total for our sum. So we've kind of got like two little end term rules going on here, depending on whether the row is even or odd. So if the row is an even row, the rule's quite simple. It's whatever that row, that column is, you halve it, but then make it negative. So if we're on, say, the rth row, or it could be the nth row, whatever you want to call it, we divide it by 2 and then make it negative. So that would work for any even row. So say if we wanted the 100th row now, well, it'd be half of 100, 50, but make it negative, so it would be negative 50. What about if it's an odd row then? It's slightly more complex. If it's an odd row, we need to go from 5 to, say, 3, or from 3 to positive 2. And what's happening there? Well, we're kind of adding 1 to the row and then halving it. So for the third row, if we add 1 to that and get 4, divide it by 2, we get 2. For the fifth row, if we add 1 to it, we get 6, then divide it by 2, we get 3. So there's the general case for an odd number of rows. Whatever row number we're on, we'll add 1 to the row number and then divide our answer by 2. So these are the two general rules for finding the value of any row in this pattern. So a lovely little task to practice your zero pair work, but also a chance to behave mathematically. Set your work out in a table, specialise, and then work towards this general case here.